We're now going to look at the bond check with pitch catch mode and how to set it up on the instrument. Pitch catch mode is used for honeycomb and foam core laminate structures. So the first thing we do obviously is connect the probe up to the unit. So we'll connect the silver end to the probe, and we also connect the yellow end to the yellow socket on the unit. When we've done that, we can turn the bond check on. Letting it go through its startup procedure. There we go, now uploading the data from the probe into the unit. This is not a pre-saved program, it's just the probe settings. What we're going to do now, prior to calibrating the unit to carry out an inspection, this is not an annual calibration, just one prior to carrying out the inspection. Go into the menu, let's have a quick look at the probe settings. Let's read them off and make sure everything's on there. So what we also have the opportunity to do, if it hadn't been configured properly, we can go down to apply probe settings and select that as well. So it's another way of doing it if it doesn't do it automatically. We can come out of that. We've been in probe, we're going to transmit next. Sweep is off, which is what we want. We don't want it in sweep mode during the calibration for the inspection. The center frequency of this probe is around about 34 kilohertz, that's correct. Everything else is okay. The only thing I'm going to go down and change is the Hanning. I'm going to take it down to 50%. The reason I'm doing this is because we are simulating setting up for an inspection or finding out if an inspection is viable. So we're going to basically run through this as if we've never looked at this test panel before. So I can come out of that, now go down to receiver. Gain is on around about 40 dB, that's nice and in the middle of the input gain area, so we should be happy with that. Everything else seems okay, just having a little look. Come out of there, we can now go down to calibrate, select calibrate. This unit has a frequency range that starts at 500 Hertz and it goes up to 50 kilohertz. If we knew, or we're looking at an inspection that had already been written for another type of unit, we could adjust this so that we sweep over a smaller area. But in this instance, as I said, we're going to carry out a calibration on this piece as if we'd not done it before. So we're going to leave it open to the maximum. But to actually adjust the frequencies, what we would do is press the green button. It's now highlighted the 500. Can't take it down anymore, but we could take it up. We could take it back down again. And the same for the stop frequency. We take it down to it, press the green button, and then we can adjust it like that. Nice and simple. Step frequency. The step frequency, or frequency step even, is the size of the steps that are taken in calibration. It will start off and it will move in 2 kilohertz steps. We'll leave it on 2 kilohertz because we want to sweep through the frequencies quickly for this video. Otherwise, you would put it on a smaller, if you could do, you'd put it on the smallest step you wanted to. It will take a lot longer, or it will take longer, but it's up to the user to use the equipment how they feel best using it. So now go down to auto gain, which I'm going to turn on. And we come out of that. Now go down to run sweep calibration. We are now ready to run the actual calibration prior to carrying out the inspection. Right then, we're now ready to run the sweep calibration. So what I'm going to do first, or next, is press the run sweep calibration. Goes into the calibration menu or settings, updating the information, and what it says down here is place probe on bond. And what that means is place the probe on a bonded area. So on the test piece, so we know this area is bonded. So we position it, put it down, press the green button, and it'll now ramp through the frequencies that we've selected. It's instantaneous frequency response there, and this is the amplitude slowly crawling across the screen as it goes through each of the different frequencies that we've selected. That's it finished. It's now updating again. Wait for it to update. It now says down here, place probe on disbond. So I now move the probe to the disbonded area. You can see a large difference there. I'm now going to press the green button again to initiate the calibration on the disbonded area. And now there's a green line, not that you can probably see it on the screen at the moment, but there's a green line being written on the bottom where the amplitude is. And the difference between them is because of the disbond. Nearly finished. So that's the actual calibration finished as such, but what it's done there is, I'll just bring it closer. What it's done is it's picked the frequency where the largest amplitude difference is, and also the quality. It looks at a quality signal as well. So that's, the system has picked this one as its best option. So what we're going to do is select that. Just waiting for the system to update itself. So now what I'm doing, move that back off of there, put the probe on here, press it down. We can now see the signal and the difference between the two. Okay, so then we've now calibrated it so that as we scan we can find the defect. So we can actually already find it, but it might be good to have some gates. So what we can do is go down to gate, select gate. It says it's turned on there, so, but we can't see it. But if we look over here, we can see two arrows in this direction. So that tells us the gate is all the way over there. So what we could do is scroll over to centre and move it back. But that could take a bit of time. You can see these arrows flash as it's moving back. Or we could, with it in centre, press the green button, and it automatically brings the gates back to the centre of the area that we're interested in. So what we now can do is change the span, which is the distance along the waveform. So we can increase or decrease that as required. Or we can go and change the threshold, which is obviously the height of the gates. So if we put it there, we'll see, if we put it in this area, away from the waveform, so it's above it, we can see that the waveform is now blue. So if we scan, nothing's happening. If we go into the defect area, it's broken the defect, it's broken the gate, and the signal's turned red. Some people like the RF display, some people don't. So we have other options. And another option here is the XY display, commonly known as the flying dot. So the way we get to the flying dot display, select the backspace to go to the menu, go down to the panes icon, select panes, and you can see pane 1, which the big pane is on RF. So if we select that, we can change that to spectrum XY. We want XY for the flying dot. Selected that, come back out again. We've now got the flying dot display. If I press the probe down, it's more or less in the middle, but if it was somewhere else, when it was down on a good area, press the balance button and it brings it back to the centre. Now we can scan around, it's moving a little bit, go into a defect area. we have quite a bit of movement. If the movement wasn't enough, we could always increase the gain. But I think we've probably got enough movement there to differentiate between no defect and a defect. So then, we've now set it up so that we have a flying dot display. When we go over a defect, the dot flies into a certain area. So what customers often want to do is set an alarm box for that area, so that they know when they go over a particular type of defect, in this instance near side, that it is a near side defect. So what we do is we scroll down to to alarm boxes, we select that. We've now got alarm boxes highlighted here. We've got number 1 selected, because in this case it is our first alarm box, so it would be sensible to use number 1, but you could slide it along to number 2 and back again. So we need to turn the alarm on. We've now highlighted that. First one we can do is a box, or we can do a circle, or we can do a sector. I'm going to do a circle this time. We can also move the circle to a certain area. We can move it up here manually by going over here and then moving it up like this, or down, or moving it along. But if it was had a distance to travel, that would take some time. So what we can do is, if we go back, to a circle here and we press the centre button, it flies up to the position where the dot is. Now if we want to go back over here, we can now change the position slightly, left and right. And if we press it again, it now changes to a cross, different type of cross. We can now change the size. We can make it bigger, a little bit, or we can make it smaller. So I'm going to say I'm happy with that. I'm going to come out of there, and it now leaves the box on the screen. So we're out and in. So we have the flying dot display, and we've seen how we can get it to go to a gate, which I've turned off now, or should I say an alarm box. So then, what we also have is something called sweep mode. Sweep mode is enabled by going into the menu, going to transmit. We have sweep mode on and off here, but before we actually turn sweep mode on, what we can do is scroll down. We have the centre frequency that the calibration picked for us for the inspection. We also have a frequency scan. So what this does is it scans it sweeps through 5 kilohertz either side, well, should I say a total of 5 kilohertz through the centre frequency of 34 kilohertz. But we can increase or decrease that how we like. So I'll just stick it up to 7 kilohertz. So we're now sweeping 3,500 either side of the centre frequency. So now I select that, go up to sweep on and off, select it, turn sweep on. Sweep has now been turned on. We can come out of here. We now go into the sweep display. You'll now see we've got a strange letter C appeared. If I balance it, we'll bring it back to the centre of the screen. So now if we scan, it sort of does a bit of changing, but as we go over the defect, there's a huge change. Very obvious that we're on the defect.